This is the continuation of our example in Wattmeter. We have next example. A three-phase, three-wire 100 volts ABC system supplies a balanced delta connected load with impedance of 20 angle 45 degrees ohms. Determine the phase and line currents and draw the phasor diagram. Find the wattmeter readings when the 2 wattmeter method is applied to the system. So we have a delta connected load which has a per phase load of 20 angle 45 in phase CA, phase BC, and phase AB. And we have these lines. Line to line voltage equal to 100 volts and line currents IA, IB, and IC. We have phase currents which are IAB, IBC, and ICA. So in delta connected load, we know that the line voltage is equal to phase voltage, which is 100 volts, and the line current is square root of 3 multiplied by the phase current. So our phase current or phase voltage and line voltage are 100 angle 0 degrees. EB is equal to EBC, 100 angle negative 120. This is the phase voltage which is equal to the line voltage. So line voltage ECA is 100 angle positive 120 degrees volts. For the phase currents, we can solve that one by Ohm's law, which is equal to IAB equal to EAB divided by ZAB. So these are per phase parameters. So that is 100 angle 0, this one, divided by our impedance 20 angle 45 equal to 5 angle negative 45 degrees ampere. For phase current IBC, we have 100 angle negative 120 divided by 20 angle 45 equal to 5 angle negative 165 degrees amperes. And also the last one, which is ICA, that is equal to 100 angle negative 120 divided by 20 angle 45 degrees. This one must be positive 120, not negative. So that is equal to 5 angle 75 degrees amperes. For the line currents, we can solve IA equal to, from KCL or the Kirchhoff's current law, we will have KCL at these nodes. So IA will be equal to IAB minus ICA. And IB is equal to IBC minus IAB. And IC is equal to ICA minus IBC. So line current IA is equal to IAB minus ICA equal to, our IAB is 5 angle negative 45 parenthesis. So lagyan nyo ng parenthesis to pag in-input nyo sa calculators ninyo. So IA is equal to 5 square root of 3 angle negative 75 degrees amperes. IB naman is 5. Of course, this is a balance, kaya pare-pareho yung magnitudes, pati dito, and also in the voltage. So IB is 5 square root of 3 angle positive 165 in anti-clockwise direction, or 5 square root of 3 angle negative 195 degrees in clockwise direction. So IC is equal to 5 square root of 3 angle 45 degrees. Or you can get the corresponding angle dito in, this one is in anti-clockwise para may makuha kang positive, or dito naman is clockwise direction. So, pwede na to. Either of the two naman. So, for the vector diagram, we have the reference x-axis. So, nandito yung, since yung phase voltage natin and line voltage is equal, so nandito yung line voltage natin which is in phase with our reference x-axis. So, EAB is angle 0, EBC is angle negative 120, and ECA is positive angle 120. And our line currents, nandito yung IA natin which is negative 75 angle, and IB negative 195. So mostly, since this is 180, and from the reference, as estimated, nandito yung IB natin. For IC, may angle siya na positive 45. So, approximately nandito siya. Solving now the value of your wattmeter 1 and 2, which is placed in wattmeter 1, the current coil is placed in the line current IA, and the voltmeter is placed between line A and line B. And also wattmeter 2 is placed, the ammeter is placed in line C, which is your IC, and the voltmeter is placed between line C and line B. So your common here is line B. For wattmeter 1, we have EAB multiplied by IA cosine theta. And theta is the angle between EAB and IA. So, same procedure natin dun sa Y connection. So, EAB is 100, IA is 5, square root of 3, and what will be the value of our cosine theta 1? So, nandito yung EAB natin, and IA is nandito. So, the angle between IA and EAB is 75 degrees. So, cosine 75. That will result to 224.144 watts. While wattmeter 2 is ECB multiplied by IC cosine theta. Cosine theta 2. This is cosine theta 2. This theta is the angle between ECB and IC. Since the given in our vector diagram is EBC, we will get the negation of this EBC para makuha natin yung ECB. So, nandito yung ECB natin, and our IC is here. So, what will be the angle of theta 2 from IC to ECB? So, since this is 180 degrees from EBC to ECB, 180 siya. And then, the angle between your IC and the reference is 45. And the angle between EBC and EAB is 120. You can solve the cosine theta or the theta 2 equal to 180 minus 120 minus 45. So it will result to 15 degrees. Getting now the value of your wattmeter 2, that is equal to 836.516 watts. The total power now of the system is the sum of the wattmeter 1 and the wattmeter 2. That is equal to 1060.66 watts. Our next example is 2 wattmeters connected to measure the input to a balanced 3-phase circuit indicates a 2,500 watts and 500 watts respectively. Find the power factor of the circuit. Letter A, when both readings are positive, and B, when the latter reading is obtained after reversing the connections to the current coil of one instrument. So this is our general formula. Tan theta is equal to square root of 3 multiplied by W1 minus W2 divided by W1 plus W2. For letter A, let both readings to be positive. So we will solve the power factor. Theta now will be equal to inverse tan multiplied by the square root of 3 times 2,500 minus 500 divided by 2,500 plus 500 equal to 49.107 degrees. And our power factor is equal to cosine theta. So power factor now will be equal to 0.655. The second condition is when one instrument is negative. So we will let that one instrument to be our W2. So we will let W2 to be negative 500 or nag-reverse yung connection niya. So solving for power factor, first we need to solve that theta. So same procedure in letter A. Theta 2 is equal to arctan of square root of 3 times W1 minus W2 divided by W1 plus W2. Theta 2 now will be equal to arctan of square root of 3 times 2,500 minus negative 500 divided by 2,500 plus negative 500 equal to 68.948 degrees. So power factor now will be equal to cosine theta equal to 0.359.